let's do this really, really very, very insane problem. I skipped this problem when I worked it, but I thought I would go over it anyway because there is an interesting idea to go over. So what's happening is you've got some kind of projectile that's been fired by some kind of spring-loaded gun. So here's my spring-loaded gun, and here's my projectile. And it says the projectile is M1. Okay, so this is M1. Now it says that the combined mass of the gun and projectile is M2. Who does that? Nobody does that. I wouldn't do the problem this way. But that's the way they set this up. So the mass of this guy is M2 minus M1. Does that make sense? The combined mass is M2, so the mass of the gun is M2 minus M1 because M1 is the projectile. And it's going to recoil this way. And what we want is we're going to say the kinetic energy of this guy is K. Well, I don't know anything about the energy. I don't know what the spring constant or anything like that. So, but I do know momentum is conserved. So I know that the momentum of this guy this way, and I'll call this sub G for gun, and then is equal to, now opposite in direction. I'm not going to worry too much about the negative sign, but it's the projectile of the projectile, and I'll call that P, sub P. So G is gun, P is projectile. So this is M2 minus M1 times the velocity of the gun is equal to M1 times the velocity of the projectile. Now, here's the thing. It's asking about kinetic energy. Here's the trick. Square both sides. And by the way, if the bell rings, I'm going to continue with this. I'm going to finish this, okay? So just quietly leave if you want to, or if you want to stay, you can. But what I'm going to do is I'm going to square both sides because I want it to look like kinetic energy. So this is just a little trick. Squared, squared. The negative goes away. I just squared both sides. Yes? Now, I'm going to divide both sides by 1/2. I mean, multiply both sides by 1/2 because I can. And now look what I've got here. I've got 1/2 M1 VP squared times M1. Do you see what I did there? I took the M1 squared and split it up. What is this? This is the kinetic energy of the pellet. And so what have I got over here? I've got 1/2 M2 minus M1 times M2 minus M1 times the velocity of the gun squared. Well, 1/2, this is the, I'm going to divide both sides by M2 minus M1. So I've got 1/2 M2 minus M1 times the velocity of the gun squared, and that's going to be equal to K times M1 over M2 minus M1. But this is the kinetic energy of the gun. And now it is in terms of the kinetic energy of the pellet. And so that would be answer D. That is all. Horrible problem. Horrible problem.